Welcome back to another video in the series Coding in R with ChatGPT. Last video we covered the simplest data structure in R known as vectors, which is just a series of numbers, a series of words or strings. And today we're going to be learning about a more complex data structure, a matrix. And a matrix you could think about as putting a bunch of vectors together to create a two-dimensional data structure made of rows and columns. So what do I mean by this? Let's just show you. So we can use the matrix function on a vector. So 1, 1, 2, 1, 1, 3. We can specify the number of columns, and then we can say by row equals to true. And this is the matrix we get. As you can see, it takes the data, the simplest data structure we have, a vector, 1, 1, 2, 1, 1, 3. And then we specify that there's 3 columns, and R knows that, or this function knows that since there are 6 data points and 3 columns, that means there must be 2 rows, and then therefore by row, or rather therefore it's a 2 row and 3 column matrix. We often say that it's a 2 by 3 matrix. So rows by columns is how we kind of describe matrices. The number of rows by the number of columns. So let's dive into some practice problems here. Or rather, before we do that, let's define x as 1, 1, 2, y as 1, 1, 3. We could also, to create this matrix, we could do a row bind. So this essentially stacks the matrix, these vectors on top of each other, x and y, 1, 1, 2, 1, 1, 3. We could alternatively do a column bind, c bind x, y, and that puts the vectors x and y together by column, as columns rather. And then to access the elements of a matrix, we can, let's say, if we define my matrix equals r bind xy, so my matrix now is this thing here, then we can my matrix, and then if we want, let's say, the number 3 in this matrix, I know we need to go into the second row and then the third column to get this value. And that's how we access elements in matrices. So let's tackle some practice problems. So create a matrix with numbers 1 to 6 with 2 rows and 3 columns. So matrix 1, 2, 3, 4, 5, 6. An alternative to doing that is 1 colon 6, and then you can see just by printing this, that produces this vector here. So matrix C1 through 6, n row equals to 2. We could, instead of n col, we could do n row, and then by row equals to true just by default. And then I suppose it's interesting, when it says by row, we can see that it goes 1, 2, 3 across the row, and then 4, 5, 6 across the row. If we did by row is equal to false, then it would default down to columns, so it would go down each column instead. But we'll do by row first. So second question, use R bind to combine x is equal to C46 and y is equal to C135. So then let's x equal to C246, y is equal to 135, R bind xy, and then there we go. There's x and y in a matrix. Use C bind to combine those same vectors, so C bind xy, and there we go. Extract the first row from the matrix M equal to R bind, so M is equal to R bind xy, and if we want the first row in M, right, which should be this and this, right, then what we want to do is the first row and then leave the second argument empty, meaning we'll just take all of them. Oops. And then that's 2, 4, 6. Rather. Let's print what M is. So yeah, so then the first row is 1, 1, 2, and then we can see we've extracted the first row that says 1, 1, 2 there. So now extract the third column from M. We can similarly do column, comma 3, and that'll give us 2 and 3. Now, some psychology problems. Create the matrix of participant responses 4, 5, 3, 4 using 2 columns. So responses equals the matrix C 4, 5, 3, 4, and call equals to 2. We can see that by default, by row is equal to false. So 4, 5, 3, 4, and then we can say that this matrix corresponds to the responses of a participant. Second participant to the first question. So if this is the matrix 4, 5, 3, 4, and then we're asked to access the response of the second participant to the first question, in psychology and in data analysis in general, typically each row represents one participant. So responses to the second participant, and the first question is typically the first column. So each question or variable represents a different column. Each participant represents a different row, typically. And then therefore 5. Moving on to the next question. Create a correlation matrix for 3 variables using matrix core. So we have 3 variables. Let's say variable A, B, and C. A is equal to, let's do matrix C. 1, 0.3, 0.5, 0.3, 1, 0.2, 0.5, 0.1, 1. And call equal 3, by row equal false, let's say. Okay, so if we have this data set, and then we consider the first column to be of variable 1, second column to be variable 2, third column to be variable 3, so data equals this. And then we want to create a correlation matrix for all the variables. I wonder if we just do core data. Yeah, so we can do that. So if we use the core function to compute the correlation matrix, we now have a new correlation matrix where the diagonal elements are the correlation with the first variable with itself, the second variable with itself, the third variable with itself. This value here, negative 0.63, is the correlation between the first variable and the second variable. This is the correlation between the first variable and the third variable. So we're always calculating correlations using the core function in R for psychological research. And this is another example, one of the primary applications of matrices in R for psychological research.